In a product market, it is products, in other words, finished goods and services, that are being traded for payments. A resource market, on the other hand, is where resources, the things that go into making goods and services, are traded for income payments. In resource markets, it's the businesses that want to obtain resources, like labor and capital, and it's the households that supply their labor and capital in exchange for income payments like wages and interest. Demand for resources is based on two things. If you are a business hiring labor or buying capital, you will definitely want high-quality resources. In other words, those resources that make the product efficiently. Also, businesses want resources like labor or capital because they make their products, and when the products are sold, they obviously generate revenue for the business. Businesses want to make products that are valued by society because they know that these are the products that will generate more revenue. Businesses will have a greater demand for workers or machines that have the capability of making valued products or services and not have as much demand for resources that are only capable of making low-valued products. The more valued the product or services, the more demand there will be for the worker and machines that make these products. We call demand for all resources a derived demand because the demand for the resources is derived from the demand for the product they make. If there is no demand for a product, then there wouldn't be demand for the resources that make that product. In short, those resources that make valued goods and services efficiently will have a high demand. But resources that make low-valued goods and services and resources that do not make goods and services efficiently will have a little to no demand from any business. In the previous units, we talked about determining how many units of output a business should make. In this unit, we'll focus on determining how many units of a resource, like labor, a business should hire. In this decision, like all economic decisions, we are going to use the golden rule. The business should operate where MC equals MB. For the business, the marginal cost is the change in total resource costs that each additional worker hired or capital purchased will bring. That amount is called the marginal resource cost. We'll talk more about that later. The marginal benefit of hiring each additional worker is the change to the total revenue that each worker will bring to the business. We call this amount the marginal revenue product. So the golden rule of economics still applies here. We're just going to use marginal resource cost as the marginal cost and marginal revenue product as the marginal benefit. So, how many workers should a business hire? They should keep hiring workers until the marginal resource cost equals marginal revenue product. Let's focus on how to find marginal revenue product. The formula for marginal revenue product is the change in total revenue divided by the unit change in a resource quantity. In other words, if one additional worker is hired, then that's the denominator, is 1. And the numerator is the change in the total revenue that one additional worker will generate. So let's say I have a business and I can sell all the product I want at a price of $5 each. Big bonus now, if this is the case, that I can sell all the product I want at a set price, what type of product market must I be competing in? That's right! I must be selling my product in a purely competitive product market. So let's say I'm selling corn. Now I'm going to add the possible number of workers I can hire in the units of a resource column. And now I add the information for what total product will be if I hired 0 workers. What total product would be if I hired 1 worker. What total product would be if I hired 2 workers, and so on. For the marginal product column, I will use the formula for marginal product, which is change in total product divided by change in units of a resource. Since I'm going from 1 to 2 to 3 to 4 workers at each step, the change in units of workers is always 1. With the denominator being at 1 at each level, then we can just use change in total product to fill out the marginal product column. At the first worker hired, the change in total product is 10. With the second worker, total product went from 10 to 19, so change in total product is 9. Go ahead and fill out the rest of the marginal product column. And your table should now look like this. If you've lost sight of what the heck we're trying to find, we're trying to get to the marginal revenue product of each additional worker. The formula for marginal revenue product is change in total revenue with each additional worker. To get change in total revenue, we're going to need the total revenue figures. So, quick, what's the formula for total revenue? Yes, it's price times quantity. Since we are selling the product at a certain price, I will take the total product numbers and multiply them by the price that product will sell at. So total revenue with 0 workers is 0 because there is 0 product produced and multiplied by $5. But total revenue with 1 worker is $50 because there are 10 units of product produced and we multiply that by 5. And now fill out the rest of the total revenue column. You should have come up with these numbers. Okay, ready to fill out the last column? The formula for marginal revenue product is change in total revenue divided by change in units of the resource. Again, since the change in the units of labor is 1 at each step, the denominator is 1 every time, so we just have to calculate the numerator part, the change in total revenue part. We will put in a dash for 0 worker level. But when we go from 0 workers to 1 worker, what is the change in total revenue? Well, since we go from 0 in total revenue to $50 in total revenue, the change in total revenue is $50. In hiring the second worker, we go from $50 in total revenue to $95 in total revenue. So the change in total revenue is $45. Go ahead and fill out the rest of the column. And your numbers should match these babies right here. So now we've figured out how to find marginal revenue product, the numbers for the right side of the equation. How about calculating marginal resource cost? The formula for marginal resource cost is change in total resource cost divided by unit change in resource quantity. In other words, for every additional worker, what will be the change in how much the business has to pay for resources? For now, let's say that this business hires its labor in a perfectly competitive labor market. This makes it easy because in a perfectly competitive labor market, a business can hire all the labor they want if they pay the market wage rate. So let's say the market wage rate was $10 an hour. A business could hire the first worker for $10 an hour, but if they decided to hire a second worker, the second worker would also work for the business for $10 an hour. The business could keep on hiring workers, and they could still find plenty of workers that would all work for $10 an hour. You will see later that this is not the case for imperfectly competitive labor markets, but for now, we will focus on perfectly competitive labor markets where this is the case. All the workers you want at the market wage rate. So now here's the same table from before, the one we used to get the marginal revenue product information. We're going to compare the marginal revenue product of each worker to the marginal resource cost of each worker. And we're going to keep this easy by assuming a perfectly competitive labor market, so this means that the additional cost of hiring each worker is the same, since they all accept the same market wage rate. So let's say the market wage rate is $50. If each worker will cost you $50, then how many workers should you hire? We'll use this rule. We want marginal resource cost to be equal to marginal revenue product. If each worker can be hired for $50, then $50 is the marginal resource cost of each worker. Looking at the marginal revenue product column and following the golden rule, I would hire the first worker because that first worker's marginal revenue product of $50 matches the marginal resource cost of $50. So I would hire one worker and one worker only, because at one worker, marginal resource cost equals marginal revenue product, but all the additional workers' marginal revenue products will be less than their marginal resource cost. What was that sound in the background? Did that mean that that was a key concept? Sure. It also meant my pot pie was ready. Now let's say that the market wage rate for the labor went down and was not $50, but $45. Now that the marginal resource cost is lower, how many workers would the business hire? Well, let's compare the marginal resource cost of $45 to the marginal revenue products. And we find that we would hire the first worker because their marginal revenue product is $50 and is greater than the marginal resource cost of $45. And we keep hiring because looking at the second worker's marginal revenue product of $45 is equal to their marginal resource cost of $45. But would we hire the third worker? No, we would not, because the third worker's marginal revenue product is less than their marginal resource cost of $45. So it wouldn't be worth it to hire the third worker if they're only going to gain you $40, but they cost you $45. So if the wage rate was $45, we would hire 2 workers. Now fill in the rest of the column for the number of workers you would hire at different possible wage rates. You should have ended up with these numbers of workers hired for each possible wage rate. Notice how the marginal revenue product of each worker determines how many workers will be hired at each possible wage rate. For example, how if the wage rate was $50, the business will hire the number of workers for which the marginal revenue product is up to $50, 1 worker in this case. And at a possible wage rate of $45, the business will hire 2 workers because $45 is the marginal revenue product of the second worker. If we graphed the 2 sets of information, the marginal revenue product on the side here and the demand for labor on the other side here, we would find that these 2 graphs were the same. Look at how on the left-hand graph, marginal revenue of the first worker is $50. And on the right-hand graph, if the wage rate was $50, we would hire 1 worker. The x and y coordinates of both graphs are going to be the same. Therefore, we combine both and say that the demand for a resource like labor is equal to that resource's marginal revenue product. So that is the main takeaway you should get from this lesson, that the demand for a resource is equal to the marginal revenue product of that resource.